And now we're looking at Chapter 3, Polynomial Functions. All right, we're looking at parts of 3.1 and 3.2 today. 3.1 is on polynomials, and 3.2 is on multiplying polynomials. Let's go over the learning objectives for this video. You do not need to write this down, but just so you know, in this video you're going to learn to add, subtract, and multiply polynomials. You're going to learn to identify the degree of a polynomial and the leading coefficient. You're going to learn to classify polynomials, and you're going to learn to do linear regression on your TI Inspire. So you will need your TI Inspire at the end of this, for the last activity on the end of this video. All right, there are some changes to the videos. All right, so these are new requirements for you starting with this video. All right, I still need you to take notes on the video, but the 3 questions that you write, those should be written on an index card, all right? Or you can write them on a piece of paper that is about index card size. Make sure you put your name on it, all right? You'll be turning that in. So I kind of like to have all of those questions from all of my students separately. All right, that's number 1. Number 2, each video is going to contain notes must-dos. All right, notes must-dos. These are going to be a few problems that you will need to do on your own, and you're going to put them right in your notes. And I do want you to draw a box around each of those notes must-dos. I might come up with a better title than that because that's hard to say. You are going to write a box around each of those, so it's going to be easy for me to check as I check in your notes that you have done those notes must-dos. All right, and that is giving you some immediate practice. All right. So with that in mind, let's begin our lesson, our video lesson. So first of all, let's talk about what is a polynomial. A polynomial is a number or a product of numbers and variables with whole number exponents. All right, and so just to remind you, whole numbers would be examples. Whole numbers would be numbers like 0, 1, 2, and so on. All right, it starts with 0 and goes up. All right, some examples of monomials would be 5x, 3x squared y, negative 4x to the 5th, w squared, 9, and square root of 3 times y to the 4th. Those are all examples of monomials. And here are some non-examples of monomials. 6x to the negative 2nd, 7x to the 1/2. Not allowed to have negative exponents, that's no good. Not allowed to have fractions or decimals as your exponents, that's no good. So those are non-examples. So what is a polynomial? A polynomial is a monomial or the sum or difference of monomials. So some examples of polynomials might be 15x cubed minus 2y, or 1/2 x to the 4th plus 3x squared minus 6. Those are some examples. Notice that each monomial in the polynomial is a term, and that monomials have only one term. All right? So polynomials, including monomials, have no variables in the denominator. They have no variables as exponents, and no roots or absolute values of variables. So that brings up these non-examples. So these are non-examples of polynomials. So none of these are polynomials. No fair having variables in the denominator. All right, that's that case. No fair having variables as exponents. So that's a non-example. No fair having roots around your variables. So you cannot have 3 times the square root of w. And no fair having absolute value of variables. So all of these would be non-examples. None of these are. Okay, so remember that all variables must have whole numbers as their exponents. So whole numbers are, as we said, 0, 1, 2, 3, and so on. All right, what is the degree of a monomial? The degree of a monomial is the sum of the exponents of the variables that are being multiplied. So let's take a look at an example. Can you identify the degree of the monomial? In this case, the degree of the monomial, this is going to be degree 5. That's going to be our answer for this one because that is the exponent right there. This one, the answer is going to be 1 because this is 7 times x, but that's really x to the 1st. So since that's your exponent, that's going to be the degree of the monomial. It's degree 1. And this last one is just a a constant. It's just 4. So it does still have a degree, though, when we say the degree is 0, because this really could be thought of as 4 times x to the 0, because you remember x to the 0 is equal to 1. So this would be a degree 0 polynomial. How about these? What would be the degree of this one? Well, to find this degree, you would need to add the exponent here with the exponent here. This exponent is understood to be a 1, so the degree here would be 3 plus 1 is 4. So that's the degree for letter D. How about the degree for letter E? Same type of deal. We need to add up the exponents on all of these variables that are being multiplied. This would be a 1 as an exponent, so we need 1 plus 2 plus 3. So that means that the degree is going to be 6. All right, that brings up our first notes must do. So you're going to put this right in your notes. Can you please tell me what is the degree of each monomial? You're going to write down these 3 examples, A, B, and C, and write down what the degree would be for each. If you'd like to pause this video so you can do that, that would be great. And then after you finish the notes must do, put a box around it on your notes so I can identify it easily. Write down notes must do number 1 so I can recognize it right away as I'm checking in your notes. Make sure you draw the box around it with your answer. So if you need to pause this, go ahead. All right, let's continue. The degree of a polynomial is given by the term with the greatest degree. A polynomial with one variable is in standard form when its terms are written in descending order by degree. So it's going to be a polynomial where the terms are written in descending order by degree. So let's take a look at an example. So here, this polynomial right here is not in standard form. This polynomial here is not in standard form. We can see the degree of the first term is 2, then it goes up to 3, then it goes up to 5, then it goes down to degree 0, right? So if we want to rewrite it in standard form, we would need to put them in order. So the negative 4x to the 5th is going to come first, because 5 was the highest power. Then 9x to the 3rd comes next. Then the 7x squared comes next. And the negative 2 would be last. What about the degree? The degree of the polynomial is the degree of the first term when the polynomial is put in standard form. So the degree of the polynomial is the degree of the first term when the polynomial is put in standard form. Well, we just put this one in standard form. So what would the degree be? It's going to be the degree of that very first term. So in this case, our example has degree 5, because that is the highest power right here. All right, just a short little break because I wanted to introduce to you my little friend here. This is Mo. He's a guinea pig. All right, let's get back to our lesson. All right, let's continue. We're discussing now the leading coefficient. So the leading coefficient is the coefficient of the first term when it's put in standard form. So for our example, which we just did, the leading coefficient would be the negative 4, because that is the coefficient on this first term now that we've put it into standard form. So our answer for this, in our example, the leading coefficient is negative 4. All right, let's take a look at this next example. We have a polynomial, 2x minus 5x squared plus 19x cubed. And let's put that into standard form. We would do that by writing the highest power first. So that would be 19x squared, then a minus 5x squared, and then the plus 2x. This is degree 3 with a leading coefficient of 19. All right, so let's talk about classifying polynomials. If we're going to classify polynomials, a polynomial can be classified in a number of ways. First of all, it can be classified by how many terms it has. So, for example, if the polynomial has only one term, we said that that's called a monomial. So one term means it's a monomial, and here's an example, like 5x squared. What if it has two terms? If it has two terms, then it is a binomial, and here's an example of a binomial, something like 4x minus 2. And if a polynomial has three terms, then we say it is a trinomial, and here's an example of that, 7x squared minus 8x plus 9. Right, that's one way of classifying polynomials, but a polynomial can also be classified by its degree. First of all, if you have a constant, that would be a degree 0, and here's an example. Just -3, that's a constant polynomial, because the degree is 0. We could think of it as -3 times x to the 0. So -3 is a constant polynomial, and it has degree 0. Then there's linear. A linear polynomial is degree 1. So here is an example of a linear polynomial, 7x minus 16. Here's an example of another linear polynomial, -6x. Okay, then we can have quadratic. A quadratic polynomial would be degree 2. And for example, that might be 4x squared minus 5x plus 1, or 11x squared plus 8. Those are examples of quadratic polynomials. That means a polynomial of degree 2. What about degree 3? We call those cubic. Cubic is a polynomial of degree 3. Here's an example, 5x cubed minus 3x plus 9, and a -4x cubed minus 1. What if it's a degree 4? If it's a degree 4, we call it a quartic. And here's an example of a quartic, 2x to the 4th plus x cubed plus 3x squared plus 5x minus 11. Or here's another example of a quartic, just 5x to the 4th. And we have a name for one more, and that is the quintic polynomial. That's degree 5. Here's an example, 7x to the 5th minus 3x to the 4th minus 4. Here's another example, -3x to the 5th plus 9x to the 4th. All right, so let's take a look at an example. In this example, we are going to rewrite the polynomial in standard form. We're going to identify the leading coefficient, the degree, and the number of terms, and then we're going to classify or name the polynomial. All right, so here is the example. 13x squared minus 5x cubed. So in this case, we want to write it in standard form first. So we need this term first. That's the -5x cubed. So here's the standard form. -5x cubed plus 13x squared. It's going to be degree 3 because that is the highest power that we see when we have the terms lined up. And the leading coefficient would be -5 because that is the coefficient of this first term when it's in standard form. All right, how about classifying it? It's a cubic polynomial and it has two terms. It's cubic because it's degree 3 and it's got two terms, as we can see, so we would call it a cubic binomial. All right, so on this notes must do, you're going to put the following polynomial in standard form. You're going to identify the degree and the leading coefficient, and you're going to classify the polynomial. It's 3x to the 4th minus 2x plus 9x to the 5th. So I would like you to write somewhere what the polynomial is. We'll put this in your notes. Feel free to pause this video if you need more time to do this. Remember, you're putting this in your notes, and you are putting a big box around it so that I know quickly where to find it when I'm checking in your notes. I want to see that you are doing immediate practice on these problems as we are discussing these topics. All right, I'm moving on. If you need more time, pause the video. Okay, so we are looking at adding and subtracting polynomials now. To do that, we just need to combine like terms. So in this first example, we are adding 3x squared plus 5x minus 1 plus 4x minus 9 plus 6x squared. You will want to combine your like terms. So we're going to combine 3x squared and a 6x squared because those are like terms, and we get a 9x squared. Then we want to combine any other like terms we see, like 5x plus 4x, so that's going to be a plus 9x. And then we want to combine any constants that we have, so a -1 and a -9 add up to a -10, and I could write that as -10. All right, so this would be our answer for this. That's how you add polynomials. Let's take a look at an example of subtracting. In this case, we are subtracting 4x squared minus 1 minus a different polynomial, 5x squared minus 6x plus 7. Now recall, subtraction means adding the opposite, like 7 minus 9 is the same as 7 plus a negative 9. That means that for this example, we can think about changing this subtraction here to addition. So I'm going to change that to a plus, but then I need to change all of these signs. I need to make that negative, make this positive, make this negative. Now we're really just adding 4x squared minus 1 plus a negative 5x squared plus 6x minus 7. So again, we look for like terms. I got 4x squared and a negative 5x squared. Remember, I'm adding, so that's going to be a negative 1x squared. And I don't have any x to the first term here, but I have a 6x here, so I'm going to write plus 6x. And then I have a negative 1 here and a negative 7 here that I'm adding, so that's going to be a negative 8. So this is going to be my final answer for this problem, negative 1x squared plus 6x minus 8. Alright, that brings up our third notes must do. You're going to do this example right now in your notes. Feel free to pause this video so that you can do this. And once you have your answer, make sure you are writing this as notes must do number 3 and that you're drawing a box around it. Alright, so you're subtracting 5w squared minus 3w plus 2 minus the polynomial negative w squared plus w minus 6. Again, feel free to pause this video if you need more time to do that. Titled it Notes Must Do number 3 and drawn a box around it. Alright, I'm moving on. Alright, now we're going to talk about multiplying polynomials. To multiply a monomial times a polynomial, you're going to use the distributive property and the properties of exponents. So, for example, if we want to do 5x squared times the quantity 3x to the fourth minus 2x cubed, notice we have a monomial here times a binomial, and we would need to use the distributive property. So we've got to multiply 5x squared times 3x to the fourth, and that's going to be 15x to the sixth, because we add exponents. For multiplying two numbers with the same base, we add these powers. So 2 plus 4 gives us 6. And then we need to multiply 5x squared times the negative 2x cubed. So that's going to be a minus 10x to the fifth, because 2 plus 3 gives us our new exponent of 5. So this would be our answer for that example. Let's take a look at one more example of multiplying a monomial times a binomial. In this case, again, we want to distribute. So 2y times a negative 3y to the fifth is going to be a negative 6y to the sixth. And distributing here, 2y times 4y squared is going to be plus 8y to the third, because the 1 plus the 2 gives us our new exponent of 3. Alright, so what about if we're going to multiply a binomial times another binomial? We can use FOIL, which I know that you are all experts at. So let's try an example of this. Let's say we're going to do 3x minus 6 times 4x squared minus 5x. I know you're getting all of these good examples down in your notes. Let me just remind you, if we're using FOIL, that stands for first, outer, inner, last. And if we're multiplying the first terms together, that would be 3x times 4x squared, which is 12x cubed. The outer terms would be 3x times a negative 5x. That's a negative 15x squared. Inner terms would be the negative 6 times 4x squared. That's going to be a negative 24x squared. And then last terms would be a negative 6 times a negative 5x, which would be a positive 30x. So we can combine some like terms. These two right here are like terms, so that would give us a negative 39x squared. So altogether, our answer would be 12x cubed minus 39x squared plus 30x. So what about multiplying two other kind of polynomials together, like maybe a trinomial times a binomial? Well, in that case, you may want to use the box method. Let's take a look at an example of that. So if we have 2x squared minus 5x plus 8, and we're multiplying it by 3x minus 1, if you use a box method, that means you're going to, in this case, make a box that is split up into by 3 by 2, and we would say 3 by 2 because we have a trinomial times a binomial. So here, for example, I can write 2x squared minus 5x and 8 as the column headings, and over here on the side of my box, 3x and a negative 1 would be my row headings. And now I just need to multiply each one of these. So if I do that, I get 6x cubed in the first box, negative 15x squared in the second box, and 3x times 8 is 24x. Then I take negative 1 times each of these and put them in these boxes. So I get a negative 2x squared, a positive 5x, and a negative 8. Notice we can identify like terms in these boxes. I've got a negative 2x squared and a negative 15x squared, and I also have a 5x and a 24x. So when I'm writing my answer, I can combine, and I can write my answer as 6x cubed minus 17x squared plus 29x minus 8. And that would be my final answer for this problem. Alright, that brings up the next notes must do, where I'm going to have you practice this. Again, I suggest the box method. You're going to multiply 3x squared plus x minus 2 times 5x minus 2. And again, I suggest you use a box method where you're going to multiply your trinomial times your binomial. You can put your terms of your trinomial here and your terms of your binomial here, fill them all out, multiply them, combine any like terms. If you need more time to do this, please pause, and don't forget to write in your notes that this is a notes must do and that this is number 4. And when you're all done with this problem, put a box around the problem and all your work. Alright? Okay, moving on. The last topic on this video is linear regression on your calculator. Alright, so this is a must-do also. I'm going to do an example with you, and you need to be doing this on your TI Inspire. If you need to go grab your TI Inspire, please push pause on this video and go grab it and come back. Alright, here's our example. The table shows the number in thousands of alternative fueled vehicles in use in the United States from the year 2000 to the year 2006. And I would like you to use your calculator to find the best fitting line and a model to describe the relationship between the year and the number of vehicles. So here's the table in question. So in year 0, so which that's going to correspond to 2000, there were 280,000 alternative fueled vehicles in the United States. In 2001, which would be year 1, there were 295,000 alternative fuel vehicles, and so on. So we're going to enter this data in our calculator. So I'm pulling up my calculator now, and we're going to put this into a lists and spreadsheet page. So push menu. You might want to start a new document. Push menu and go to option 4, which is add lists and spreadsheets. All right. At this point, right up here in this top box, we might want to type in year. Alright, and then I need to get to the next box here where I might want to type in vehicles. Alright, then I'm going to enter my data here. I have year 0 data, 1, 2, 3, 4, 5, and 6. And at this point, I want to enter the number of vehicles, and that data, let's get back to my my table, was 280, 295, 322. 395, 425. 471, 511. Okay, make sure you push enter after this last one. Don't leave it looking like this. You need to push enter so that 511 is recognized by the calculator. At this point, remember this was a list and spreadsheet page, and now we're going to add a new page to this document. We're going to add a new page, and that is going to be done by doing Control Doc, and we want to add a data and statistics page. When we do, there's our data. It's just not organized yet, so you want to get your cursor down here at the bottom, click, and we want our independent variable to be the year, so click on year. All right, all our data lines up, and then over here click and vehicles. All right, so there's our data. It looks somewhat linear, so we want to get an equation that would model this data. All right, the best fitting line. And so to do that, we're going to do Menu, Analyze, and Regression. And once we choose, let's try this again. I was clicking too slowly, I think. Menu, Analyze, Regression, and we want Linear Regression. All right, you've got two different choices. Don't worry about that. Just pick one of them. And so we get this equation here, and it looks like y equals 41x plus 262.571. So that's the equation, the best fitting equation for the line that goes through the heart of the data. It doesn't hit every point, but the line goes through most of these points. So for this must do, I will expect you to show me on your calculator that you have this done. All right, and that concludes this video. Make sure you write your 3 questions on an index card or on a small piece of paper that's about index card size, so I can collect them all and have them all. Make sure your name is on it. Make sure you have all of the must-dos done on your notes, in addition to having this must-do in your TI Nspire calculator. All right, have a great day, and we'll see you next time.